Next, top, Next topic is block diagram reduction techniques. The block diagram reduction technique, it consists of a single block or a combination of blocks. These are used to represent the control system in pictorial form. Signal into the block represents the input R of S and signal out of block represents output C of S, while the block itself stands for the transfer function G of S. Flow of information is unidirectional, output being equal to input multiplied by the transfer function of the block. The need for block diagram reduction technique is, it is normally required to reduce multiple blocks into single block, or for convenient understanding it may sometimes require to rearrange the blocks from its original order. For the calculation of transfer function, it is required to be reduced. The basic elements of block diagram is summing point and takeoff point. The block diagram reduction technique is basically modeling of any simple or complex system. It consists of multiple blocks connected together to represent a system to explain how it is functioning. Transfer function, it is a ratio between transformation of output to the transformation of input when all the initial conditions are 0. This simple block diagram is shown in this figure, and also complex system is shown in this figure. In simple system, the input R of S is given to the system G of S and the output is C of S, which is given by G of S equal to C of S divided by R of S. Basic elements of block diagram is block. Here X of S is the input, G of S is the system, and Y of S is the output. Y of S equal to G of S into X of S. The summing point is Y equal to A plus B, and if it is negative signs, Y equal to A minus B. Block diagram reduction techniques have some rules. The first one is combining blocks. The original diagram consists of G1 and G2. We can combine it as in a single block G1, G2. Combining parallel blocks, which is shown in this table. Here, while combining the G1 and G2, we must add G1 plus G2. Moving a branch point ahead of the block represents, if G1, we want to moving a branch point ahead of the G1, it will be changed as 1 by G1. In G1, we want to moving a branch point before the block, it came as again G1. Moving the summing point ahead of the block, it is transferred and added again one more G. Moving the summing point before the block, we need to add G and 1 by G in that summing point. Block diagram reduction technique rule number 7 is elimination of feedback loop. The original diagram shows the two blocks G and H. Its equivalent diagram is given by G divided by 1 plus or minus GH. Combining blocks which are in cascade or in parallel. While combining the cascade blocks, it is represented by multiplication, and while combining the blocks is in parallel is represented by plus sign. These are some of the rules in block diagram reduction techniques. Eliminating a feedback loop, swapping with two adjacent summing points are all changed into these equivalent diagrams. The assessment question is, find the transfer function of the following block diagrams. Here the block diagram is given. By using the above studied rules, we need to reduce these complex block into a simple block using block diagram reduction techniques. These are the solutions to reduce the complex block into a simple block by using the rules already we studied. Wherever we apply the rule, any rule here. Thank you.